Today our video lecture is about KNN, that is K nearest neighbors classification method. Sometimes it's also used in regression method as well for prediction of class of a sample. So let's say you have a class of a sample of x underscore new, as it says here in the script, and there are three steps. So first, we need to calculate the distance between the sample x new and each training sample. So for each training sample, its features and the classes are supposed to be known. So how to set up that training sample, I will show it to you later in the script. Then after that, the next step is to find the k nearest neighbor, and then you will assign the sample x new to the class that occurs most frequently among that k nearest neighbors. So k is actually a parameter called a hyperparameter, and it's mostly assigned by or assumed by an user for the purpose of classification. And most always or typically odd values of k are considered for breaking ties while during the classification. We are going to use a new library scikit-learn for classification and loading of sample data sets. So we are going to use a previously created dataset called iris dataset. It's a famous dataset and it has three different species of flowers called three different species. The names are Setosa, Virginica, and Versicolor. So it's a famous data set used for classification methods, and it contains, as I said, three species for iris flower. So let's first load the iris data set using the sklearn or scikit-learn. To do that, you need to import the data sets from the sklearn and then into iris. The iris dataset is to be loaded using the load iris function. So using the dataset, you need to load it. Now the iris has the dataset, and now let's say you want to see the description of the whole dataset. What you can do, you need to run the code like this, and it will show you the whole dataset in this format. So iris dataset, it has three different classes or species, as I said, and the features that we are going to consider are four features: sepal width, and petal width. These are four numeric predictive attributes of the classes. So this is the summary statistics and some more details about the iris dataset. So you got the description. Now, like next thing is that you need to pull up the species name. Let's say you don't know the species name, as you are going to use those species names in your classification. Let's find out those species name. So assign to x variable, you need to assign the iris dot data. So every entry has four attributes. As I said, sepal length, sepal width, and petal width. And target means an array of name of labels, that is the same three flower species in the dataset. So X contains the attributes, that are the features, and the target will contain the species names. So let's say now you want to print all the target names, suppose. So how to do that? Use the iris. Now the iris has the whole data set. So use iris dot target names. It will give you all the target names that are available. So it is same as of your y. So if you also want to print y value, it will give you the same example, same output here. Now the data actually contains the features. It's used for making the predictions. The target contains the class values or the species values or species names, and they are mostly stored in the format of a numpy array, which is the collection of elements, and this is the dimension like this. So now let's say you want to find out the shape of the numpy array. So these are three species, but how are they organized in the data set that you want to see? As you want, we are going to make the classification. We should be aware about the values of each attributes or features. So to get that, X contains the data. So if you find out the shape of X, so it should give you number of rows and columns for X. So which is 150 and 4 number of rows and columns. And Y, which has the target, its shape is your 150 rows. So all the flowers has this many rows and 4 columns. So 4 columns for 4 species, 4 features. That is your sepal length, sepal width, petal width. Now got an idea about X, Y. So let's say you want to print the value of X and Y. So just run the code and it will give you all this set of values. So what does it mean? Here 0 means this is one species. 1 means all these values belong to another one species, and 2 means this one belongs to another one species. So whether 0 may point to setosa, 1 may point to versicolor, or 2 may point to these are all the values. Okay. Now the next two important things are feature names and target names. As I told you earlier, the the number of species in our data set is same as of your target names. That is your setosa, versicolor, virginica. Okay, if you run it, it will show you the output. And the feature names is nothing but your features, that is sepal, petal, length and width values. So after you got all those details, let's say you want to form a data from all those values. So X contains all the data, and that you have from the feature names. So try to assign them to columns. Now, if you want to form the data frame, it will be formed in this way. So each column will belong to each one of the features and their respective values. So they all total, there are 150 rows and 4 columns. So if you see the X dimension, we have found out like this 150 and 4. So this is what you get, 150 and 4 columns. Now, let's say this is a 2D NumPy array. We want to traverse through or iterate through the 2D NumPy array. So, what are we supposed to do? Let's start with the array, okay, X array plus the corresponding target, okay. We will start here by outputting each row of the X array. See, here I have already ran the code and see what is given here. So for each flower, it's giving a set of value, okay, and it's like all the feature names, and this is the species number as well. So sepal length, sepal width, and what type of flower, that is what species it is having. So all those details are to be um, outputted through this set of code. So it will enumerate over the X, the NumPy array, and it will list all the rows, put it in L, and one by one append them to L. And now iris combined will append them all the list values, and iris combined will have all these values. So now if you see, for 2 you have the feature values, for one species you have all the features values, and the 0 also contain the respective feature values of the flowers. Now you got some idea about the iris data set. Now the next thing is to create a new list columns that will contain all the column names, which are nothing but your feature names plus your species. So how to do that? So from the iris.feature names, copy that, put it in columns, and then each species that you have previously. Okay, where do we have the species? Okay, it will automatically, oh sorry, it's a value, it just will print the species name up here because we want to add a column. So column names now will have all these values. So using all those column names, we are going to form a data frame. So iris combined have all these values from here. Using iris combined and the column names, we are going to plot a data frame in this way: 150 rows and 5 columns, 4 features and the species name, species number accordingly. Now we have a thorough picture of our iris dataset. The next thing is to visualize the data, to see how many species do you have, how many numbers are they correctly identified or not. So for visualization purpose, we are going to use a seaborn module. So if you see this statement, import seaborn. So we will use a seaborn module to generate a scatter plot. So this type of plot is called scatter plot with dots. So different colored dots belong to different type of species. This is for 0, this is for 1, and this is for 2. Now from the SNS Seaborn, you will call the scatter plot function, put the value for x and y. X is the first column. These are nothing but the sepal length and which have an index of 0 if you see. Okay. And then y contains the sepal width which is column x and has an index of 1. And you are coloring everything on the basis of the value of the y. Hue is set to y. Set the x level, that is sepal length, y level as sepal width. Set up the title in this way. Okay. So this is all. After running this code, you will get the visualization of the graph in this way. This is called a scatter plot. So here you got an idea about how 3 different types of species are being classified. Now let's move on to k nearest neighbor. Our main function begins from here. So scikit-learn module provides a framework for working with the KNN classifier and involves 3 basic steps. Those steps are: first, create an estimator model called the k neighbors classifier. We will see that how to create a KNN classifier. Then we will train the module using train function, and then we will predict the model using the prediction function. So first let's start with the starting step, create a KNN classifier. So here let's see. So from the scikit-learn, using sklearn.neighbors, you will import the k-neighbors classifier module, and this will implement the k-nearest neighbors algorithm. Okay, so first, using the k-nearest neighbors and using the k-neighbors 3. Why we are taking 3? Because there are 3 species of the iris flower set. And you are going to create an estimator object KNN for the k-neighbors classifier. Let's try to print it. It will give you the classifier name along with the k-neighbors value. Now the second step is to train the model. Let's see, to train the classifier. So the general step is to use the model name dot fit xtrain and xy ytrain. So what is this now? So how is it used? Use the model name. So what is your model name? You got it. The object k-neighbors classifier object as knn. Use the model name knn. Then use the fit function. So the fit function should use the x and y value. So xtrain is an array of features for your training data. So it will contain all row corresponding to sample and columns corresponding to all features, and y is an array of labels corresponding each row of xtrain. So it got the values x and y. Now when you run the code, it will fit the model. Now we will make prediction. So how to make prediction? So you can use this format, model.predictxnew. So here actually, let's take our example. So you need to import the numpy because x new that we are going to use in our predict function for knn. It is a 2-dimensional array which contains features for the samples. And what type of prediction are we are going to, on the basis of what? On the basis of 4 features that we have, that are these: sepal, petal length and width. Okay, so let's take an array random values. So let's say the sepal length is 6, Sepal width is 2, petal length is 4.9 and petal width is 1.5. If you use the numpy array, add it to assign it to x new, and when you try to predict x new using this feature values, it will give you array. You need to run the code, it will give you array 1. So 1 here actually belongs to our species called versicolor. 0 is setosa, 1 is versicolor, 2 is virginica. So it means that or the flower which has these values of sepal length, petal length and sepal width, petal width values, that falls on the versicolor species. Okay. Now let's see how to use the training and the testing data set. See, first we need to understand while evaluating the model, it is basically simple. You need to split the data set, use the XY value, test size and random set. So while evaluating the model, we should have both the training and the testing data, and they should be independent. Okay, and if a testing data set is not used, we will not know if the classifier is overfitting the data. We will go into that later. Actually, overfitting means when the classifier works really well on the data set, but performs very poorly on new data. That is something called overfitting. It gives us so much accuracy so that so in some type of data, in the new data, it will perform poorly. So in this syntax, X is a matrix containing feature data. Okay, and let me show you it here. So we need to import the trends test split module from scalar and model selection to split the data for training and testing sets. So here the trend test split will take the input X, that is the matrix containing feature data, Y corresponding to the matrix containing class labels. X will have features and Y will have the species names. And test size, how much amount of test data you want to assign, that depends on you, but ideally it's best to have this percentage 33%. And random state, it's for setting up a fixed value or set so that results will be reproducible. And yeah, so that's all. And what it will do when you run it, it will automatically split all the data. And let's say after split, X train, X test, Y train, Y test will have some value or portion of data. So let's say you want to see the shape of all those things, so just take it in this way. X train dot shape, it will give you 100 rows and 4 columns. Okay, so like that, you can have the shape of X test, Y train, Y test as well. So now our data is split into testing and training sets. Now, next thing is to fit the model. So to fit the model, this portion I just set up a counter to find out to see how many each of the classes we have in trainings. Like I said, it's not important. Basically, to have an idea about for white train, what is the counter? That is 35 of Setosa. Two species have 34 and one species have 31. Like that, this counter also white test has this many. It doesn't have any importance, just to have a clear view about it. Now let's fit the model. So using the training values of X and Y, you will train the model. So now it's trained. Now after trained, now next thing is to make prediction using the test dataset. Now you will use X test. So this is the statement for it. And when you print the pred, it will give you the 50 samples in the test dataset. So when you run it, it will give you all these samples. So 2 belong to a species, 0 belong to one species and 1 belong to another one species. To have more clear specification, we need to evaluate the results by generating a classification report. I mean, how is our classification method KNN is performing. So for the performance measure, we need to find out the classification report. So how to use it? You need to import it from the sklearn.metrics. Okay, and there is a classification report function we need to call, and it takes the input white text, bread, which is being predicted earlier, and the target names. This should be the inputs to classification report, and it gives you all these values. Precision, recall, F1 score, support for our Setosa versicolor virginica flower species. See all the values. So precision is actually what? The proportion of values for a class that have been classified correctly. So if you see, Setosa is classified correctly. Versicolor is classified for about 94%. Virginica 88%. We don't have any problem in Setosa, but some problem with versicolor and Virginica. Recall is the proportion of predicted values that are classified correctly. F1 score is the mean of precision and recall. I have included a link about it, how to find out F1 score. Please go to look into this link. And support is number of samples of each group. Total number of samples for Setosa 15, versicolor 19, virginica 16. Okay, and the accuracy, macro and weighted average is also provided for all the column values. Now, after we have this result, we are sure that Setosa is being identified properly and correctly. So, to evaluate the result, again using another one method called confusion matrix. So, what is this? This is a matrix structure. It will come in this way. So, we need to import the confusion matrix, and what it does actually, the matrix actually shows the observation in each row, that is for each class corresponding each column. Okay, so it's actually useful for identifying where the classifier may be confused, and from our observation we have seen that our classifier is confused for versicolor virginica. I'm sure you understood this, why I'm saying. And yeah, so let's see. So confusion matrix will have the this syntax, that is white test will be assigned to white true and pred will be assigned to y prediction. So mostly you will have to provide the values for y true, y prediction. Using that you got this value. So what does it mean? First row is for Setosa, next is for versicolor, third one is for virginica. So 15 samples of Setosa are identified correctly, and none of the Setosa are being misclassified because we have 00 here. For the second row, versicolor, so 17 species has been identified correctly, but 2 is being misclassified or identified improperly. The same thing goes for virginica. 15 species are being identified correctly and 1 is being misclassified. Now let's create a data frame from this. Use the confusion values, use column names and the target names. So this will give you this format of data frame. So you now got an idea that what does this matrix means. So matrix is in this format. Setosa versicolor virginica, Setosa versicolor virginica. So if you see here, Setosa is identified correctly and it is not being misclassified as versicolor or virginica, whereas versicolor 17 samples are correctly identified as versicolor, but 2 samples are wrongly classified as virginica. And for virginica, 15 samples are correctly identified as itself virginica, but 1 sample is incorrectly identified as versicolor. Okay. Let's say you want to show it in another format. That is a format called heat map. For our SNS is for scikit-learn. So SNS.heatmap in this format will give you the same confusion matrix as a heat map structure. Okay, so the misclassification will start from dark red color and proper identification will be in the blue color. So 15 is proper identification. Okay, so here is our conclusion. So if you see the accuracy from the classification, you could observe that out of 15 Setosa, all 15 have been identified correctly and none of them are falsely identified. And in the same way, 17 versicolor identified correctly, virginica is identified, 15 samples are identified correctly. So from here, the average accuracy, if you want to predict, is your 94%, which is your weighted average. This is your accuracy. Okay. This classification algorithm yielded you the accuracy of 94%. Like this, you could also use some other classification algorithm instead of k nearest neighbor, which may give you some more amount of or percentage of accuracy, and you can go with that. This is all about your k nearest neighbors.